Recording now. So, how's everyone doing? I was just thought I'd put this out there that okay, all right, some of that. Okay. The nervous assignment is due there today. I think y'all are well on top of that. Your last test is there next week. There is no lecture. This is it. I just want to leave you guys with something there. I think I said it there earlier. It's self-reflection is a tool that I ended up learning later in life, and look into self-reflection and just the empowerment that it has. And not right now, but sometime there today or tomorrow or whenever, you know what I mean? You just look back, you look at who you are now and think back to, hi guys, if you're just joining in, we haven't done anything. I'm just talking. I'm recording though. Look back 11 weeks ago. And you know what I mean? It doesn't seem like that far. It's only 11 weeks. Like, what is that? I don't know. Is that almost 3 months? Yeah. And look at who you were then, look at who you are now. And, but first and foremost, know that you are no more intelligent than where you were 11 weeks ago. And I don't mean that in a bad way. I mean it in a truthful way. You were just as intelligent as you were 11 weeks ago as you are now. The only difference is that you guys are learning to learn again. And a lot of you guys have returned to school, and some people have been out of school for a decade or more. And you guys are doing this as a group. You guys have made friends. You guys will always have my email. I have students that bother me from like 4 years ago. And they're at Guelph and they're doing this and that and they update me and all that. And I love it. And, I have stuff that I have access to resources that you don't. So a year from now, you're in, I don't know, some biochemistry class doing something, you know what I mean? Go get a bachelor degree. Go get a master's degree. You guys are smart enough to do it. If you guys can get through this in 11 weeks, you guys can pretty much do anything. No joke. This has probably been one of the most brutalist courses I've ever taught. And our class average right now is in the high 70s, which is outrageous in a good way. So you guys just keep on going. Know that you guys are doing this, and you guys use that tool. Reflect back to who you were 11 weeks ago. And there won't be major differences, but pick and choose little things there that you have just maybe instinctively or unconsciously changed. You guys have done this, and you guys are going to do it. All right? There's no doubt about it, as we say here in Canada. Boy, did I ever get razzed for my accent. We don't think we have an accent here in Canada, but we, Americans, they say house. We say house, these kinds of things. But just keep on going. Next week's test is going to be, it'll be at least 100 questions. Oh yeah, it's 25%, right? So you've got, respiration. We've got digestion. Like, those are beasts unto themselves, right? But now we throw in, what did we do there yesterday, or last week there, the beast of all beasts, urinary. And then today we're going to do reproduction. And a little bit, you'll see there. It's we're going to do reproduction and why is it not coming? We're going to do something else. Yeah. And it's just been a nutty day. Wife's gone to work. Both kids. We got neighbors' kids over, and they're anyway. Long story, but I hope you guys are doing all right. I don't see any issues. Some people have spoken to me, and I'm aware, and everything is good. But I don't really see any big time issues. Next week's test will be the same. There'll be true and false. There'll be multiple choice. There might be some matching. You know what I mean? It'll be the same style. At least 100 questions. But other than that, it'll be it'll be the same time frame. Like I'll probably open it at 8 o'clock in the morning and keep it open till midnight. So you know what I mean. People who are working and doing this and doing that, they'll have time to do it. And so no changes, no nothing. Yeah. Do you guys have anything? Any questions? No, Esther. It's all good. It's all good. Am I missing anything? Shut up, Ian. Let's get on with this. All right. I get it. Let me get my stuff in order here, and I'll be. Yeah. Oh, and yeah. Nah, I'll talk about that later. All right. Let me screenshotting. All right. Okay. That's all right. Hey, if your computer's got to update, I'm going to record this there, and I am recording it now, and it'll be up on YouTube pretty soon. Okay. So, if you guys have any questions, you guys know the routine. Just holler, interject, scream, shout, do whatever you guys got to do. We just kind of chatted about next week's test. So there's no class. Test will open early. It'll finish late. It'll be the same routine. It'll be a bit of a smackdown. It'll be at least 100 questions, but same style. But we've got basically 6 units: respiration, digestion, urinary. There was a bit of water and minerals there. We've got reproduction there today. And then we're going to do a little bit on hereditary. Dominant recessive genes, why we have blue eyes or brown eyes, these kinds of things. You know, like what's that one called? A widow's peak? We'll talk about these kinds of stuff. And you have to think that if this is a 100-question test, I've got 6 units to talk about. So you're probably looking at, but we'll talk more about any specific questions there. But here we go. If I'm missing anything, let me know. All right. But here we go. Reproduction overview. The primary role, there's a theory that's out there, and I don't know if it's called the gonad theory or what I'm going to call it the gonad theory, but it's just the whole idea, like our brain, that's us. The little person inside here with the mechanic, he's operating the stick shift. The little person, that's our mind. That's our consciousness, right? We are in control of ourselves. I think, therefore I am, right? By Descartes. But then there's the other theory there that says the little person behind the ears who's controlling all the levers and buttons and gadgets is really being controlled by our testes and our ovaries, because our gonads, our testes and our ovaries, they are the ones that are pushing us. Why? The whole point is reproduction and to maintain our species. Now, whether I'm a squirrel or a dolphin or whatever, you know what I mean? There's the two opposing, we have sex hormones, we have gonads, we have them there, and they are there to reproduce. And which one is in control? Are we here to reproduce, or are we here to go down the slip and slide at Wet and Willie's Wild Wet World? You know what I mean? What is what is it? Who knows? Just two opposing theories. Okay. I think everyone has an idea. I'm pretty sure everybody has an idea about reproduction. All right, so it's not going to be that bad of a PowerPoint, but what is going to be a little brutal is, again, we're into a Latin course. Okay, there's going to be, you just have a look at this slide right here. You know what I mean? Look at all the words. It's all right, though. You know what I mean? Maybe there during the week, you could pull off all the words and onto a word sheet, like a Microsoft Word, have definitions there for everybody. You could share with everybody. You guys, you know what I mean? Involve me, whatever you guys need, because there are a lot of new words here. So, gametes. we'll get into these guys here. So the primary role of the reproduction function, reproductive system, is to produce haploid gametes. Now, it's been a long time, or it seems like it's been a long time since we've done a little bit of DNA. Okay, and DNA, that's our genetic blueprint. That's what we pass along to our kids. These kinds of things. Yeah, Latin should be a prerequisite. Oh, I hear you on that one. But the egg, which we'll call the ova, okay, I'll get into all these kinds of things, and the sperm, they are not a true representative of your DNA. However you identify, if you've got eggs or you've got sperm, if you take the DNA out of that sperm cell, or if you take the DNA out of that ova, it doesn't look like yours. Doesn't look like anybody else's. And we'll get into these kinds of things because half of the father's DNA joins with half of the mother's DNA. Half plus half makes 1. And we'll get into these kinds of things. There's another interesting point there that if you are a parent to multiple children, which I'm sure a lot of you guys are. I'm one. And the more children you have, the more that you'll see that the DNA coming from you in either form, ova or sperm, is never the same. And you know what I mean? If you take, I don't know, from a female there, you take 10 ova, 10 eggs, and examine the DNA of each one. Number one, they're all complete. Number one, they're all half of the mother's DNA. Number two, they are all completely different. And it's something that, because if I was giving my DNA directly to my kids as it stands in my cells here, that would be a genetic no-no. Because now whatever diseases I am susceptible to with my DNA, now my child will be susceptible to those, and it doesn't work like that. It's called genetic variability, where my DNA, what they do, and we'll get into this process here, they take, my body takes half of the DNA and tosses it in a salad, like a pizza maker, and then it rearranges it all so that now my children and your children, there is a greater safety net. But we'll get into all these kinds of things here. Production of gametes, so that's sperm or egg, is called gametogenesis. This involves meiosis. There's meiosis and there's mitosis. Okay? Know the difference. Mitosis with a T, mitosis, that is where you take a cell and it completely copies itself to make 2 new identical cells. That's happening right now in your body, in your skin cells, your bone cell, all these things. They are replicating, making duplicates. But in gametogenesis, though, it's called meiosis. And we'll get into this. This is that genetic variability we were talking about. Evolutionary safety net. We'll get into that. Where each cell, each new sperm cell or each new egg cell is not the same. That's why if you have multiple children, they could be, most likely they will all look different. All right, we'll get into all that kind of stuff. Gonads, testes, and ovaries. In males, spermatogenesis, the making of sperm. In females, oogenesis. Now again, if I'm saying it improperly, it ain't an English class, and I don't care how you say it, as long as you know that that's oogenesis. All right, the making of eggs. All right, it's all regulated by steroid hormones, and these will all seem very familiar to you. Testosterone, estrogen, progesterone. We'll get into all these. I have some good videos here. I don't know if I can play them or not, but I really want you guys to play them. Let's go. So haploid just means half. So you see, haploid gametes are produced through meiosis, called gametogenesis. And this means half. We'll get into this. Haploid gametes are the egg and the sperm, and they contain 23 chromosomes in human. We're going to get into a germ cell that undergoes meiosis. Okay, these are diploid. Okay, you, me, right now, we are diploid. We got 2 strands of DNA, one from mama, one from papa. Together, they wrap around each other. That's in a nutshell, and they come together, and that makes you, or that makes me. As we said there before, a sperm cell or an egg cell has only got half. It's haploid. And then it joins with the ova, and then it becomes diploid. Okay? Good. I run over the same carpet many times in this. Okay? Male reproductive system here. We got the testes and the spermatic ducts there. The testes, they produce the sperm and the testosterone. There's ducts, okay, that travel through, and their purpose is for transport, storing, and if you didn't know, the sperm has to be aged. There you go, before it gets out. You're going to hear accessory sex glands. These are important glands, but they're kind of subsidiary. Okay, like everyone knows the testes and all these kinds of things here, but the seminal vesicle. These are words you're going to see. I've got diagrams here. You've got the prostate gland, which men over 40, they need to watch because that is a cancer center. Okay. There's also another one there called the bulbourethral gland. These secretes semen there, which assists in the movement of sperm. Okay. Supporting structure there, the scrotum and the penis. Okay. We've got that there. Here's some shots there. And all of these are good. You know what I mean? Here we have the testes. There's the scrotum. What connects the testes there to the rest is what we call the epididymis. Okay? And here's one of these vesicles travels up here, which now we call the vas deferens. And for males who get the snip, okay, that's what gets snipped right there. Okay? Just a little snip right there. Honestly, I think it's, I don't know, is it like a 20-minute procedure? You know, so that's it right there. Travels around here. There's your, you remember there from last week, this is the bladder. And this is one of your ureters. You'll know, you remember you'll have 2. And those there connect up to the kidneys. Okay. And then we've got our, we'll talk about these here. Seminal vesicle, ejaculatory duct. There's your prostate gland right in here. Okay. There's your bulbourethral gland. And urethra. And out. Okay. Here's just another shot of it. Okay. Yeah. Let's get into it. And if you guys have any questions, let me know. The scrotum there holds the testes. Okay, the scrotal cavity there divided by the septum to form 2 sacs, one for each testes. So they have their own little sacs there. Skin, fascia, smooth muscle, contract. Hello? Hello? Are we good? Okay. Skin, fascia, and smooth muscle contract and relax in response to external temperature. The main reason why the testes are outside of the body is that maximum sperm production or spermatogenesis occurs at a temperature there. I think it's about 2 or 3 degrees lower than the normal body temperature. Okay, so that's why there is a reason why the testes are actually outside the body, because they need a little cooler temperature to maximize spermatogenesis. Okay. What do we got here? The testes there, they're kind of bilobed shape. It's kind of like a, let's just call it egg-shaped. Okay. They sit in the scrotum there. The seminiferous tubules there in each lobule there. They contain the spermatogenic cells there that produce the sperm, and there are two of them. Okay, there is Leydig cells that secrete testosterone. Okay, and Sertoli cells that support spermatogenesis. And what we've got right here is the pathway of sperm. Okay, so you got your seminiferous tubules. Okay, so right in here, sperm moves out to my ready testes. You'll see out here. So my seminiferous tubules are all right in here. Okay, and then the ready testes, and then out the efferent ductiles to my epididymis, and eventually there my vas deferens here. Okay, so this is the these are the testes, kind of in a nutshell. Okay. Accessory glands there, they secrete semen. Like the sperm, you'll see there that it actually, I don't know if you guys remember, this is crazy that it 9 weeks ago, but see if you, what is the powerhouse of the cell? Anybody know? Starts with an M. Every cell will have a powerhouse. Mitochondria.
Mitochondria?
Hey, who's that?
Me.
Me. Okay, thanks, me. Very good. Excellent.
John.
Thanks, John. I just saw the name pop up. Very good. Yeah, you'll see there that these guys actually have their own kind of mitochondria. They have their own they have their own energy source, because the sperm, they got to move, right? There's this flagella, which we'll get into, and what's making this thing move. So the semen, there's a lot more that's going on in there than just sperm. Okay, there's fructose with as an energy source. We got all the there's the fluid itself, because you have to think there that the sperm leaves the male and goes into the female. Okay, that's a foreign environment. Okay, so the seminal fluid is actually a protecting factor in making sure that the sperm can get to their end destination in a foreign environment. So, but we'll move these there. Seminal vesicle, prostate, and bulbourethral, and these guys are here. These guys here assist in the secretion of semen, which assists in the movement of the sperm. Okay. And you can see we're not going into crazy detail. It's more about awareness. Okay. The next PowerPoint there that we'll do after this one there, it goes into detail about embryology. You know what I mean? Right from sperm meets egg becomes a zygote. And then, you know what I mean, it turns into a marula and these kinds of things. I'll talk to you guys about that. We're not going to go into that crazy detail for that part. But here, these things here aren't so bad. The seminal fluid there is actually alkaline. It's basic. Okay? And it helps, because you'll remember there from last week's lecture there that urine is slightly acidic. I think it was a pH of about 6. Yeah, somewhere in there. And so the seminal fluid is slightly basic, because it's got to travel through, and just the odds of there being, you know, some acid there in the male urethra, because the seminal fluid has got to come out the urethra as well, the same place as urine goes. So it's all just about a matter of protection. Helps neutralize and protect sperm from the acidic male urethra. Has a high concentration. Yeah, you need that. You better have a coffee. Great, there's a fruit fly in my coffee. Wonderful. Lucky I found that out after I had a drink. Has a high concentration of fructose, and you'll know that fructose is a sugar. Okay, sucrose, fructose, glucose, right? And it's used in ATP production. So the sperm has got it all, man. Okay, it's got its own little engine. It's got a food source. It's on a mission, as we all know sperm does. Okay, it also contains something called prostaglandins, which I'm not going to test you about there, but they contribute there to sperm mobility, and contract smooth muscle in the penis and female reproductive tract. Interesting point. Prostaglandins actually have an effect on the female reproductive tract. It gets it stimulated. Okay, when the seminal fluid is deposited there in the female, what happens is now the female uterine tract starts to move. Okay, and which then encourages the sperm to travel up. We got the neighbor's kid there downstairs, so the three of them there. We'll just see how long something goes until something gets broken. It's all right. I can hear them screaming and having fun. The prostate gland, prostatic fluid mixes with the sperm. Okay, the mix of fluid causes the sperm to move. There's citric acid is involved in ATP production. That's what. So the prostate there is involved in the making of the seminal fluid. Okay. Bulbourethral gland there, located inferior, okay, just below the prostate on either side of the urethra. The erect penis there stimulates the release of alkaline substance into the urethra, okay, which neutralizes and makes it safe there for the sperm to travel through. You'll see here there with this, here's a cartoon of a shot of a sperm, one spermatid. And you'll see here that there's the tail, okay, which we call the flagellum. Okay, here's your mitochondria, okay, all this there in the mid piece. And then on the head here, which we call the acrosome, okay, you'll see, okay, acrosome on here. And what happens is there's an enzyme on here that is specifically there to do one job, and that is to break through the membrane of the egg cell. And that's what this enzyme does, and it's located right there on the head of the spermatid. Okay, sperm have three sections there: the head, mid-piece, tail. Don't forget about the 23 chromosomes. We'll get more into DNA in a little bit. Okay, but remember there that this is half. Okay, half of what we have. That's all we can give. We can't give. If our sperm just contained my DNA, I'd be sending out exact copies of myself. But you have to think there that if the egg was doing the same thing, the egg has the DNA of the mother, completely identical, wouldn't even need sperm, right? Because then the egg could just grow. So the egg has half DNA, the sperm has half DNA, 23, 23 come together, makes 46. Okay? Genital ductways. Here's the path as we've seen there before. You've got going up the epididymis there to the vas deferens, around again there to our ejaculatory duct. And you'll see there the difference. Here's my bladder. Okay? And when the bladder, you know what I mean, it gets extended there and you got to go pee, well, you just go pee, right? But then for intercourse there, okay, here's the ejaculatory duct, which uses the exact same duct as the urine just did. So that's the whole point of getting an alkaline solution in there, just to kind of clean it all out and ready to go. Okay. Please have a look at this, meiosis and mitosis. I'm not going to go too crazy on it, you know what I mean, at all, you know what I mean? But it'd be really good for you guys to know the difference between mitosis and meiosis. And I'm not talking specific, you know what I mean? Just know that mitosis is for body cells, somatic cells, okay? The, like regeneration of skin cells in my arm, or right now on my forehead right here, these, you know what I mean, cells are regenerating, and you're taking one cell and just making a copy. That's it. That's mitosis. Okay? Meiosis, different ball game. That's only for spermatogenesis, oogenesis, the making of gametes. Okay, gametogenesis. Okay, but we'll get into, I'll show you, I have a couple of interesting slides there that, these two cells here, these are the two cells that I want you guys to know. But again, how much detail can I ask in a multiple choice question, on this? Because I've got so much information to cover. So, but you can expect one of these there, guys, to be on there for at least a question. Sertoli cells there. Like the brain, there's a blood barrier. Okay. You remember we said there that the blood doesn't actually touch the brain because it's a safety measure, right? Because the blood, we need the blood, but the blood can also carry pathogens and be a vector for disease. So we separate that, and the same thing happens here because, we need to protect these. Which is strange enough because we can live without testes or ovaries, but the body protects them very well. You almost think, who's in control, right? The Sertoli cells there, blood testis barrier, support spermatogenesis, produce androgen-binding proteins, stimulated by follicle-stimulating hormone. And I have a great video on the 2 weeks there of the female reproductive cycle there, and outstanding. Graphics are killer. So we'll get there. Yeah, and if any sperm are formed and they're improper or don't cut the mustard, they get the chomp chomp, phagocytosis. Leydig cells produce testosterone. Okay, and you have a look here. This is how kind of the whole process works there in spermatogenesis. There we have the Leydig cells, which you will remember produce a testosterone. So we have the Leydig cells right here, and we have this basement protein. So, and what evolves here is what we call a primary spermicide. Okay, now again, I'm not going to go into crazy detail here. I think that this is important stuff. You guys can pick and choose what you think is important, but you know what I mean. This is important stuff here. You have a look, primary spermicide, and it divides. And you'll see there that it divides again. And they are not the same. Because this guy here has got DNA. All right? It's got half the DNA, 23. And then what happens is it doubles. It makes a copy of that. But DNA starts to get mixed up. And it's called this whole idea of genetic variability, is that if DNA is just going to be copied generation after generation after generation after generation, the person at the end of those generations there is going to be a pretty weak individual, because society, the earth evolves, new diseases come out, global warming, climate change. These things didn't exist 30 years ago. Environmental factors happen. And you see, this is the way the body is on top of things. Okay? Every single generation is monitored for environmental factors, which will then influence what goes on. And just the whole idea, in the 1600s in England was the Industrial Revolution, where they found that coal, okay, they could burn coal, boil water, get machines working, steam engines, combustion, all these kind of things. Factories started to happen. The Industrial Revolution of Europe, okay, but for the next century it was very black. The coal is dirty. All the buildings were covered in black smoke. All the trees were covered in black. And what happened was these moths that were white, they all got whacked because they were sitting on coal-covered buildings. And what happened was, in a matter of a year, these moths changed to all coal color. It's documented. You can go on Google and find it. And you see, it's what we call a mutation. And there are mutations going on now everywhere across the world. Okay? Some mutations don't work. That individual dies out. You know what I mean? That bug or squirrel or, these kinds of things. Sometimes, though, these mutations, they work out and they end up being the dominant species. So this is this whole idea of the body maintaining its attachment to relevant day 2021. Because these sperm cells are all different. The egg cells work the same way. And this is how it goes here in a nutshell. So this is a primary spermicide, okay? And it's got 46 chromosomes here, and what happens is it divides into 23 and 23. And then it'll divide again, okay? And it's making copies. So these are from one, we get 4 spermatids, sorry. And the whole point that I want you guys to make, I'm not interested in anything on here, first meiotic division, I'm not interested in that. I just wanted to show you guys the whole idea of genetic variability. That from one, we get 4, and they are all different. They're all different. And if any of these make it, they have a chance just like everybody else. Okay? But the DNA and all these guys is different just for those environmental factors out there. We don't know what the world is like out there, so we got to prepare for it. And that's just the body's way of staying in touch. This spermatogenesis movie, please watch it. It's awesome. Awesome graphics. It goes into all this. I think it goes into more detail than you'll need. Okay, but the graphics are really cool. And if you're watching this on video from YouTube, pause it, watch the video, and then come back to me in 5 seconds. The testes there, we've got follicle stimulating hormone, which you've heard there before. And if you haven't, you're going to hear about it there today when we get into oogenesis and ovulation. Okay. Yeah, FSH is in males and females, okay, and in males there it stimulates the seminiferous tubules there to produce sperm. We have LH, which is luteinizing hormone, okay. Interstitial cell stimulating hormones, they stimulate the interstitial cells to secrete testosterone, okay, testosterone there, Leydig cells. Negative feedback. Okay, so when there's not enough sperm, then we start kicking in the gears there, luteinizing hormone to get more sperm going. And when this too much sperm is made, or if we have enough sperm is made, what happens there? That shuts off the LH, and so therefore now we don't need any. Okay, and that's what we call a negative feedback. Today you're going to learn about something called a positive feedback, if you haven't already heard about it there. Okay, child labor. No, I don't mean illegal child labor. I mean in labor giving birth to a child. Sorry, completely different things. Okay, what do we got here? Effects of testosterone, sperm development, primary sex characteristics, maturation, enlargement of the penis and testes, deepening of the voice, hair. Okay, your body distribution will change. Generally, they're thickening the muscles or enlarging of the muscles. Okay, the voice deepens, skin thickens, these kinds of things. Okay, that's the effects of testosterone. Female. Here we're going to list and describe the structures and functions of the female reproductive system. We're going to go into a bit of hormones. Okay, describe the structure of the breast and lactation. And various methods there. We'll see. The female reproductive role, produce eggs, secrete hormone, and in the case, this isn't really telling the whole story, produce an egg. Okay, but there's a lot more that's going on there than just producing an egg. Okay, the female reproductive tract not only produces the egg, but sends the egg around every month, looking for the sperm, looking to make the zygote. But in the event that a zygote is made, okay, a zygote there meaning a diploid cell ready to divide and become a human being, the female reproductive tract is ready, willing, and able to accept that, house it, protect it, nourish it, and then after 9 months, safely eject it. So, you know what I mean? That's the whole thing. It's quite amazing. Okay. These are words there that I'll show you there in a diagram in a second. Ovaries, the fallopian tubes, the uterus itself, the vagina, the vulva, okay, mammary glands. That's what these guys are here. You'll see. And I like the other one. There's another. Do I have the fundus here? I don't have the fundus. I am going to get the proper shot of the fundus. But what we have here, there's your uterus. Okay, here's the vagina. And the opening there to the uterus there is the cervix. Okay, and to each side of the uterus there, we have ovaries. Okay, here's your fallopian tubes. And you'll see these finger-like projections there close to the ovaries there. We call those fimbriae. Okay? All right. What we've got here, this is the vulva, and this is the opening there to the outside. You guys can have a look at that there. And again, getting into the ovaries and egg production, there's that word again, meiosis. Now, you remember there in spermatogenesis, there we had a primary spermacite, which then each one divided again. The DNA gets all shuffled around like a tossed salad, and at the end of this, we actually have 4 spermatids, right, that are all different because we want them that way. It's the exact same process, kind of. We'll show you there when we're talking about oogenesis, okay? And again, we've got follicle-stimulating hormone as we did in the male, and we've got luteinizing hormone here. They do different purposes for the same purpose, though. FSH, ovum becomes Graafian follicle. Okay, so the egg is released here with luteinizing hormone ovulation. Okay, the movies there, you guys can hear me do it, but the movies there, they just you get it in 5 minutes. Everything is there. So and actually these PowerPoints there from this book aren't very good, but we'll keep going here. Estrogen. Okay, the males there we have testosterone. Okay, the ovarian hormone there we're talking estrogen. Promotes maturation of the egg. Makes a female look female. Secondary characteristics include maturation of reproductive organs and breast, characteristic fat distribution. Okay. The skeletally, male and female skeletons look kind of the same, except for the pelvis. The pelvis bones there on the female are wider proportion there than they are for men. Okay, and that's just for giving birth. We've got menstruation kicks in. Okay, and closure of the epithelial discs in the long bones there. Interesting. Estrogen does that. Solidifies them a little bit. Okay. What do we got? Oh, now we're getting into where I want to be. Okay. So, the female reproductive system here contains the ovarian follicles. Each follicle contains 1 ovum. Okay? Primary oocytes, like the primary spermacytes, okay? Interestingly enough, the male, they're producing them kind of as they go. Primary oocytes, for female, they're developed within the follicle, and these are all formed by infancy. It's already done. Done. And you'll see there that women begins puberty with about 400. I've seen 500,000, 400, let's just say a lot of these follicles already ready to go. And then every month, one gets released. One gets released. So what? 12 a year times, I don't know, let's say 30 years. So what's 12 times 30? That's 360 eggs. That's it. 400. 400 eggs. That's all that get released out of 400,000. Crazy, eh? The follicles mature during the menstrual cycle. Mature follicles release an egg, which constitutes the ovulation. What else we got? Here's a good shot there of the female reproductive system. I like this one a lot better. Here's your vagina here, cervix there. Okay, this is your uterus. Okay, here are your fallopian tubes. You have 2 of them. So these are your fimbriae and these are your ovaries here. And so what will happen, and don't take my word for it, watch the video. An egg will get released here, okay, with those 2 hormones involved. Remember, luteinizing hormone and follicle stimulating hormone? Those 2 guys there, they start the whole process. All right. So anyway, an egg gets released. The fimbriae, okay, they kind of scoop it in, so the egg comes up here. And, you know, a big problem, I don't know if any of you have ever heard of an ectopic pregnancy, where the implantation of the cell, it's the implantation of the zygote, which is that's the cell there that's going to be a human being, okay? We like it to be implanted in here, okay? Please note, 3 linings there to the uterus, okay? Important, absolutely. Because you'll see there the inner lining is called your endometrium. Okay, and that's where we like the zygote, that's where we like the baby to be implanted, right in here. And then you have your what's called your myometrium. This is kind of the, for the lack of the better word, the meat, the muscle of the uterus. This is where the contractions come from, right? When a child is ready there for birthing. Okay, and then the outside there we have your perimetrium. Okay, definitely know those 3 because you guys have maybe you've heard of, maybe you haven't, very serious disease there called endometriosis. Okay, which I think we kind of talk about there at the end. Okay, but getting back into what's called an ectopic pregnancy, where the baby gets implanted up in here. Oof, it's a bad one. Bad one. We don't want that happening. So it's all monitored and all that. We like baby to be down in here. Please have a look at the, we call this there the infundibulum. This is called your fundus of the uterus right there. Okay. Yeah, everything is good there. I like that slide. That's a good one. Know that one. Okay. The fallopian tubes there, about 4 to 5 inches in length. Smooth muscle. Interesting. You guys know what that all is, eh? Smooth muscle and cilia. Cilia. Where else do you find cilia? In the lungs. Okay, those little hairs there that kind of move mucus and all that, move stuff around. That's what's going on there. And it's all there for transporting the oocyte. All right, well, we'll see how this goes here. Maybe things are all falling apart. The lipids and glycogen there, you will see microvilli. Hey, guys! Good. Thank you. See you tomorrow. All right. Get to it. You'll remember microvilli. You remember there in the small intestine, you know, those little folds, villi, microvilli that are involved in creating a massive amount of surface area for such a limited amount of space, right? Well, same thing goes on here. All about maximizing space. There are 3 segments there, the fallopian tubes. You have your infundibulum. Okay, it's right beside the ovary. This includes there your fimbriae, those fingers. Okay, you got an ampulla, most likely site of fertilization, and we've got the isthmus there, connects to the uterus, distal to the ovaries. Okay, we've got the perimetrium, the myometrium, and the endometrium. Okay, and you guys can have a look at those. Those are pretty important stuff. Okay. Tube troubles, ectopic pregnancy, fertilized ovum implants in the fallopian tubes, scarring and blocking of the fallopian tubes, often caused by repeated sexually transmitted diseases, a big time cause of infertility. Okay, we don't want those fallopian tubes to get scarred and blocked up, because if you can't get anything through, you can't get anything through. Okay. PID, which is also called pelvic inflammatory disease, genital tract opening directly to there. Yeah, just an inflammation there. Okay, pretty common. Oogenesis, kind of the same thing as what we did there, analogous there to the spermagenesis process. Okay, just like in spermatogenesis there with the primary spermacite, we get a primary oocyte. Same banana. Okay, it's got double, it's got 46. Okay, and the oogonia there, they stop this mitotic cell division around the 7th month of gestation. Anyway, I'm not interested in this. You just need to know that the spermatogenesis and oogenesis, the same process. You start off with the primary and you end up with 4. And I'm going to show you this right here. Yeah. And all of this stuff here I'm not interested in. It's just a visual representation of what's happening here. Okay? You get 1 and then it'll break up into 4. I have a better shot of it there coming up. Hormonal control of reproductive cycle. A number of hormones there. They control the female reproductive cycle. Unlike male hormones, female hormonal secretions occur in a monthly cycle. And I'll show you which video you'll need to watch there for that one. Okay. The purpose there is to mature an egg monthly for fertilization, because the body, it's too much work to keep the female in a state of, what's the word, chemically speaking, ready for pregnancy. Like, that's a lot of work that the bot, and I'm going to show you what's going to go on. You can't maintain this. It's got to be a procedural thing that builds up and then is taken away, and then we'll build it up again with the hope of getting pregnant, and then coming away here. And you'll see what we'll show you guys here, these there, what's going to go on. The yeah, where am I looking at? Right here. And you'll see what goes on. You've got your primary oocyte right here, okay, which then leads to this follicle. And this is what is released, okay? And you look at all the work involved in all of this. Look at this empty space in here, okay? And sperm breaks in, and it's got everything that it needs right there. Okay, I'm going to skip ahead to this one right here, and I actually want to watch this one there with you. I think this is it.
To understand the various ways that medical science can assist reproduction, it is important to understand how the reproductive system functions in...
Can you guys hear that? Is everything, yeah, okay, that's all I needed, thank you.
Both sexes, because the cause of infertility often lies equally with both men and women. The main players in the female reproductive cycle are the pituitary gland, the ovaries, and the uterus. Their activities are closely coordinated. Each month, one or other ovary releases a single egg, an event known as ovulation. It is brought about by a series of complex interactions between the pituitary gland, the ovaries, and the uterus. The pituitary gland is itself under the control of this small area of the brain known as the hypothalamus. A new menstrual cycle begins when the nerve cells of this center secrete a hormone called gonadotrophin-releasing hormone, GnRH, into the network of blood vessels which surrounds the pituitary gland. Stimulated by pulses of gonadotrophin-releasing hormone, cells in the pituitary gland secrete another hormone, follicle-stimulating hormone.
And you see, this is the anterior there, pituitary, and the gonadotropin-releasing hormone there sends a message here for this guy there to now produce FSH.
Or FSH. FSH travels in the bloodstream, reaching the ovaries.
And you'll see there with the endocrine system, you know what I mean? There's no duct or anything. These hormones there are just sent out into the bloodstream randomly. And they only have one target, the ovaries. All right, and once they get there,
it stimulates the formation and growth of an ovarian follicle in one or other ovary. The follicle consists of an egg, a number of surrounding cells which secrete estrogen hormones, and fluid. FSH helps the egg to mature and prepares it for release. As the follicle matures, the hypothalamus increases secretion of GnRH. This in turn stimulates the pituitary to secrete a second hormone which acts on the ovary. This is luteinizing hormone, or LH. Toward the middle of the cycle, there is a sudden peak in the blood level of LH. This acts as the trigger for ovulation. Within minutes of its release, the egg is guided by suction through the fringed opening of the outer end of the fallopian tube, starting it on a journey which will take 5 or 6 days as it passes down the tube and finally reaches the cavity of the uterus. Meanwhile, after the follicle ruptures, it is converted into this yellowish body known as the corpus luteum. Cells of the corpus luteum secrete the hormone progesterone, which brings about important changes in the lining of the uterus, preparing it for possible pregnancy. In fact, the lining of the uterus, known as the endometrium, undergoes changes in response to hormone levels during the cycle. In the first half of the cycle, known as the follicular phase, the developing follicle secretes increasing amounts of estrogen hormone, which encourages regeneration of the endometrium. After ovulation, there are important changes in the endometrium, aimed at making it suitable to receive a fertilized egg. These changes are brought about by a secretion of progesterone from the corpus luteum.
so you see what's going on here. This is the endometrium. This is the inside lining there of the uterus. And it's building up tissue. It's anticipating pregnancy. Okay?
The secretion of progesterone is maintained for several days, but if the egg is not fertilized in that time, the corpus luteum withers, and falling levels of progesterone and estrogen trigger the shedding of the uterine lining as the menstrual flow. The cycle then starts again.
Okay, so that's that in a nutshell. Now, are we going to go there? It is important stuff there. We've got FSH, luteinizing hormone, is important there to both aspects of male and female reproduction. That's what I wanted to show you guys there. Okay. And this is the same, basically the same as what the slide there was just talking about. You know, the initial FSH, okay, is released there. Okay, travels there to the ovaries, and then LH is released, which then kicks off ovulation. Okay, and then the whole process goes along. The corpus luteum, okay, have a look at that one there. That's from the disrupted follicle, egg cell, okay, and it produces progesterone, which has an after effect. if the egg doesn't get fertilized. So have a look at that one. There's some good stuff there. And here's just another shot of the same banana. Okay? And here's your hormones involved up here. And if they're high and low, you can correlate them there to the, pretty much there to the day, okay, of the cycle. And have a look at it. Good stuff. Good to know. There's your corpus luteum, dead or alive. Dead, so it's without the fertilized ovum, okay? The plasma levels of our ovarian hormones there decline. Without hormonal support, the uterine lining sloughs off, okay? If it's alive, okay, if it's involved there with a fertilized cell, the hormones persist and they maintain the uterine lining. So if the egg is not fertilized, well, then the lining there, the endometrium, starts to shed, resulting in menses flow. Okay? But if the egg is fertilized, that endometrial lining isn't going anywhere. It's ready to go. It's been bolstered up there for the past 2 weeks. It's ready for implantation, and that's what happens. Okay? So, summary there for reproductive cycles there. You guys can have a look at this. It's all right. When we get into the menses there, and somewhere, you know what, you hear about women giving birth now into, I think I read there that some lady gave birth in her 60s. Now, I'm not sure what went on there because generally in the late 40s, can happen earlier, can happen later, but somewhere in and around the 40s or so, females experience what's called menopause, which is a decrease in the ovarian hormones. Okay, the menstrual periods there, they decrease and eventually cease and desist. They stop. Okay, and female breast and lactations there, we've got the mammary glands, 15 to 20 lobes. We've got the alveolar glands there located. They secrete there the milk into the ducts there for the breasts. Okay, simple terminology there. Hormone involved there in lactation, estrogen, progesterone. During the 9 months there of in utero, the breasts increase in size there because they'll have to feed baby when baby comes out. Okay, we get into something there called prolactin and oxytocin. Lactose. That's how I remember this. Okay, lactose is milk sugar. So prolactin is involved in milk production after birth. Know that one. Oxytocin. This is another one I want you to know. Okay? This one here comes from the posterior pituitary. Okay? And this is the one there involved in labor. Okay? And we'll get into more of this there. But oxytocin stimulates labor. And with the onset of labor, with a healthy delivery, you're going to need milk. Okay? So that's that one there. Yep. Same thing there. Oxytocin stimulates the breast smooth muscles there to contract, releasing milk. Okay? The diseases of the reproductive system there, we've introduced there endometriosis, PID, and we've talked about prostate cancer. Prostate cancer is a killer, man. Please, you guys are about to enter medicine or the medical field. And for goodness sakes, I've said this 1,000 times and I'll say it 1,000 more. Don't stop there. Keep going. You know, whatever dream you have, go get it. You all need a reference. It's all good, and so, but when we're talking there about these kinds of things, you need to be aware, because where you guys are going, you guys might see these in patients there, and it's good to be aware because they will need accommodation of some kind, and they need to be accommodated. All right, they're the patient, they're the ones who are ill, and that's where we're headed. Okay, endometriosis. That with the endometrium, right, the inner lining there, the uterus, endometrial tissue grows outside the uterus and starts growing on other organs. So you have this endometrium that is not in the endometrium. See, the endometrium there is the inner lining right in here, right? But what will happen now is that the body will make a mistake and it'll think that another organ over here is your endometrial lining. And it'll start, it's a bad one. I don't know if anyone has it that you know of. From what I understand, it's not a good one. Okay? And so that's endometriosis. Sorry, I'm just trying to find my other slide. There we go. Most often, endometriosis is found on the ovaries, on the outside of the ovaries, fallopian tubes, tissue that holds the uterus in place, outer surface of the uterus, lining of the pelvic cavity. Oof, it's not one there that is that nice. PID, or pelvic inflammatory disease, an infection of the female reproductive organs which occurs when sexually transmitted bacteria spread from the vagina to the uterus, fallopian tubes, and ovaries. Okay? And like that's the whole point of the cervix, right? It opens and closes. It's a line of defense. Okay? Because you have the vagina, you have the urethra right there, two openings to the outside world. Okay? But you're pretty close to everything that's important inside, you know what I mean, the ovaries and these kinds of things. So the PID is quite common. Pain in the lower abdomen and pelvis, heavy vaginal discharge, these kinds of things, pain and bleeding, something there to be to look over for sure. A dose of antibiotics will take care of that. Okay. Prostate cancer, yeah. One of the most common types of cancer in men. And getting back to my point there, I want you guys and not only apply this at work, apply this at home, apply this with your family. Health has to be proactive, not retro. Okay? You gotta, even when you're talking cancer, stage 1 is doable. If you catch it early enough, continual testing, continual monitoring, catch these diseases in their infancy, they're easy to take care of. Catch these diseases in stage 4, don't even want to talk about it. Okay? So your health, your family's health, your patient's future health, please start to take a proactive approach to health. Health is a maintenance thing that you start today and you do daily, and prepare for the inevitable, okay? Or not the inevitable, but you want to safeguard against diseases there. Mutations, okay? These can come from, like you look at the DNA. You know, these massive molecules, these chromosomes, which we'll get more into there next PowerPoint, but massive molecules, when they replicate in mitosis or when they kind of replicate in meiosis, right? When they're switching and all these kinds of things. There's a lot going on there. And if there are mutagens involved, like like you guys have all heard of antioxidants. These come from blueberries and kale and purple vegetables, all these things there that don't taste good, right? Isn't that always the way it is? The healthy things don't taste as good. Or I guess we'd all be over cheeseburgers and pizza. Okay, yeah, blueberries, I got you, Andrea. Blueberries are good. They're high in what's called antioxidants. And these are these molecules that can literally take a punch. And why are these molecules, these antioxidants, important? Okay, because out interacting with the environment, you know, we can walk beside a barbecue that's going high energy, fire, smoky, black tar barbecue smell, right? We breathe it in. Or people who smoke cigarettes or drink excessively or all these, you know what I mean? There's household cleaners, be very careful of household cleaners. Okay? The whole idea that, I'll get into this, our whole idea of what clean is has been altered there by advertisers. But just take care and be proactive with your health. These antioxidants there, when you breathe in cigarettes or all these type of mutagens there are these high energy molecules. They're very volatile. And how do you get cancer? One of these high energy molecules bangs into a DNA as it's replicating, and now you have two copies, but they're not the same because they were supposed to be the same. And now you've got two copies that are not you, and then they divide and they divide and they divide, and there's your cancer. Okay? And these antioxidants from blueberries and all these, what they'll do is they'll hit one of these high energy molecules and suck up all of its high energy. So now it is not a carcinogen anymore. Now it is not cancer. Now it's just something to be peed out, okay, or excreted. So that's why these antioxidants are so important, because they reduce the risk of getting cancer. And how do you get cancer? From mutagens in the abnormal cell's DNA, cause the cell to grow and divide more rapidly than normal. And all these cancer cells, they not only are they blocking and taking up space there's not a lot of space in the body, but they're also using resources at double the speed. Okay, and depending upon the type of cancer, you know what I mean. Blood cancer is the worst, because where's the cancer? It's in your blood. It's everywhere. All right, so just be proactive on the health. Sorry for the rant. Some of these things here, I want you guys to pick and choose what is you think. I think you guys know me by now. Okay, my tests, there might be one or two specifics, but generally where I'm at is I'm looking for generalities there. Okay, we've got those. That is it. Do we have any questions there for reproduction? How are we doing? I'm going to stop sharing right now. And wow, there's still lots of people here. Hi, very good. Let's take, what is it, 1:15? Let's take 10 minutes. Let's take 10 minutes. We'll see y'all back here at 1:25? And we'll finish up the other PowerPoint. Is that good? I'm going to stop recording and get out of here. Bye, guys. We'll see you in 5, or see you in 10. Now, let's stop recording.